Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into a 12th grade topic, geometric series. Now, if you're new to my channel, I'll be putting time codes in for this video in the description box below, so use it to skip ahead to whatever part of the video you think is most interesting. As always, if you have any questions about what we see today or even your own homework, you can always put in the comment box below or visit my Facebook page at Tutor Me Sempai and tell me all about it there. At the end of this video, I'll be linking my 12th grade playlist in which I cover a lot more topics. So if you're interested in that, make sure you stay tuned. This video is only going to have 2 parts, so leave a like, smash subscribe, and let's get started! In an earlier video on this channel, we've already covered arithmetic series. And today we'll be covering geometric series. In fact, you'll see that there are a lot of similarities between the 2 series. The first similarity you're going to notice is that they both start with their respective sequences. Arithmetic series comes from an arithmetic sequence. Likewise, your geometric series will start from a geometric sequence. So let's say we have 1, 2, 4, 8, and it just continues. We have this sequence here. It just continues. This is a geometric sequence. We have a common ratio of what? Well, 1 times what gives us 2? 2. 2 times what gives us 4? 2. 4 times what gives us 8? 2. So we have a common ratio of 2. So this is a geometric sequence. And in order to change this sequence into a series, just like we did for an arithmetic series, we would remove the commas and put your addition signs here. And you're just going to add up all the terms in your sequence, making it a series. This is now a geometric series. Another similarity that you will see between the arithmetic series and the geometric series is that they both have the ability to be either finite or infinite. This is going to be an infinite geometric series. You would simply make this finite by removing this ... Now we have a very fixed, very finite geometric series. So they both have that option of being either finite or infinite. Another similarity that you may see between the 2 series is that they both have formulas to help you evaluate the series. So the arithmetic series had a formula. This one is also going to have a formula. So the formula for the geometric series is going to look like this. Your a sub 1, your first term of the series, over 1 minus r, your common ratio, times 1 minus r to the nth power. And n is going to be the number of terms in your series. Now you can write this formula in a different way as well. You may see it either way, so just so you're prepared, 1 minus r to the n, 1 minus r, all times a sub 1. Either one of these, if you run into it, it's the same thing. You're just moving things around a bit. But this is going to be the formula that we're going to use to evaluate your geometric series. We'll talk more about this formula in another video. However, there is a difference between the 2 series that I want to highlight that deals with this formula. Unlike our arithmetic counterpart, this formula can actually be used to help us evaluate infinite series. Now, we didn't have that option for our arithmetic series, but for your geometric series, there is a chance that we can use this to evaluate what an infinite geometric series would be. But once again, we're going to talk about this in another video, specifically targeting this formula. So now that we've covered a little bit of the basics for your geometric series, let's jump into a few examples to see if we can identify what type of series we have. Do we have a geometric series? Do we have an arithmetic series? In fact, do we even have a series? Is it a sequence instead? In these examples, we want to identify what we have. Do we have a series? Do we have a sequence? Is it arithmetic? Is it geometric? Is it finite or is it infinite? We want to identify each and every one of these, and it'll be a couple more after we finish the first 3. So let's look at the first one. We have 1, -5, 25, and -125, and it seems like it keeps going. what is this? Is it a series? Is it a sequence? Let's start there. Well, this is going to be a sequence. This is a sequence. We're not adding anything. We're listing the numbers. Remember, your sequence is going to be a list of numbers. So this is a sequence. Is it geometric or arithmetic? Well, this is going to be geometric. You're not adding the same thing. You're actually multiplying this by -5. Multiplying by -5. Multiplying by -5. So you notice that your common ratio is going to be a -5 here. So we have a geometric sequence. It's geometric. Geometric. Now, is it going to be finite or infinite? Well, we can clearly see that it continues. So this is going to be an infinite geometric sequence. Let's move on to number 2. What do we have here? We have 20, 30, 40, 50. There's some addition signs, so that should give you a clue. This is going to be a series. It's not a sequence. We have addition happening. This is a series. Is it geometric or arithmetic? Well, it seems like we have a common difference of 10 as we move down the series. So now we have an arithmetic series, but is it finite or infinite? Well, this is going to be finite. It's not continuing. This is a finite arithmetic series. How about our third one? What is this? We have -3, -6, -12, -24, negative ... What do we have here? Well, it's definitely not a sequence because there's no commas here. This is actually going to be a series. However, you see that we have a lot of negatives here. Is it geometric or arithmetic? Well, going from -3 to -6, if we're supposed to be adding things for our series, what's actually happening here? Well, it seems like we have a common ratio of 2. You're starting at -3, you're multiplying by 2, you're staying negative, but you get a -6 now. Multiply by 2, you're staying negative, but you have a -12 now. So your common ratio is actually a +2. However, this looks a little different from what you're used to because you're not adding up everything, you're subtracting everything. But this is still going to be a geometric series. Is it finite or infinite? Well, this is going to be infinite because we're continuing this series. You're subtracting whatever comes next. Let's look at a couple more. For our number 4, we have 2 minus 10 plus 50 minus 250. What is this? Is it going to be a series or a sequence? Well, this is definitely going to be a series because we're adding up everything. Although we're subtracting as well, but it's technically still adding. But we're adding up everything. It's not a list of numbers. So we have a series. Is it going to be geometric or arithmetic? Well, let's look. We have a common ratio of what? If we were going to go from 2 to 10, we're going to have a 5, but it's negative, so we're multiplying by -5. So from -10 to 50, we're also going to be multiplying by 5, or a -5. From 50 to -250, once again, a -5. So we know that our common ratio is going to be a -5. This is definitely going to be geometric. Geometric. We have a geometric series here. Is it finite or infinite? Well, this is going to be finite because it's not continuing. We have a finite geometric series. How about number 5? We have 2 minus 11 plus 50 minus 249. What is this going to be? A series or a sequence? Well, this is definitely going to be a series as well. This is a series. Is it geometric or arithmetic? Well, let's find out our common ratio or common difference. Clearly, it's not the same common difference, but let's see if our common ratio is going to be the same. We have 2 to 11, and we have 11 to 50, and then from 50 to 249. Where we can see that in order to get to 11, it's not going to be the same common ratio from 11 to 50. So this is definitely not going to be our geometric series. Neither is it going to be an arithmetic series because things are just not panning out. So we actually don't have either in this case. This is just going to be a regular series. However, we can tell if it's finite or infinite. Is it finite or infinite? It's not continuing. Therefore, this must be a finite series. Now, a series is just going to be adding up a sum of numbers or a list of numbers. Adding up a list of numbers. That's your series. It's just not going to be geometric or arithmetic. How about our last one? We have 20, 27, 34, 41, ... What do we have here? Is it going to be a series or a sequence? Well, this is definitely going to be a sequence now, because it's a list of numbers. Is it going to be arithmetic or geometric? Well, let's find out. Do we have a common difference or a common ratio? Well, if you look from 20 to 27, it doesn't seem like it's going to be a common ratio, more like a common difference. 20 to 27 gives you 7, so you have a 7 here. 27 to 34 gives you a 7. 34 to 41 gives you a 7. You're adding 7 to go to each subsequent term in this sequence. Therefore, this has to be an arithmetic sequence. Is it finite or infinite? Well, that ... lets you know you're going to keep going. So this is going to be an infinite arithmetic sequence. Well, I hope you were able to follow along with today's video, and I hope you now understand the basics of your geometric series. However, if you have any questions about what we saw today, or even your own homework, you can always put in the comment box below, or visit my Facebook page at Tutor Me Sempai and tell me all about it there. If you hadn't done so already, remember to hit that like. It surely helps the channel by letting YouTube know that you found a video helpful. And if you found a video helpful, so can someone else. So leave a like, hit the notification bell, smash the subscribe button, and share this video with a friend. Well, that's all the time I have for today. I really hope this helped with your homework. I'm looking forward to seeing you again next week. I'm Courtney. Here's your playlist, and this will be the session of Tutor Me Sempai.